Question 1. We are told to differentiate the following y equal to 2x times exponential to power x. Okay, so if you look at this one now, this is a two functions. This can be called u, while this one can be called v. So the dy, the x be equal to, you take one constant, we can take these 2x constants and differentiate the other functions, okay, then plus the one you are differentiating here, you can keep it constant and differentiate 2x. So that will be equal to what? If you differentiate 2x, that will be what? That will be 2. That will be 2. So this is a product rule. So the final conclusion will be equal to 2x. If you differentiate exponential, it will give you back the function, because the derivative of this power here is 1. So, and then plus 2ex. So that's that on that question. But note, if you are differentiating exponential functions, okay, let's say for example you have 2x, okay, so derivative of exponential function is that function, okay, but we must multiply by the derivative of the power. You must multiply your answer by the derivative of the power, and that's what? That's 2. In this case, this is part of our question. The derivative of this power is what? Is 1. So that's 1 times the function itself, and that's what? That's ex. Okay? So question 2. We are told to evaluate the following with respect to x. With respect to x, give your answer in exact form. Okay? So if you look at this one now, this is a fraction, and this is a fraction. And I think the best way to do this is to use change of variable. And by the time you use your change of variable, you see something that will be similar to the variable here. This one will cancel out by the time you use your change of variable. Let's go straight. Question 2. Integral of upper and lower. This is a definite integral to 24x all over 6x squared plus 1 dx. So this is what we have now. And then when you are using change of variable, it's better for you to take the function, the expression that look bigger, that look complex. Okay, so let u, this is a power 2, this is power 1, so this is higher than this one. So let u be equal to what? 6x squared plus 1. Okay, then the u, the x, differentiate this function respect to x, and that will be equal to what? 12x. Okay, then the next thing to do now, can we make the x the subject? So the x will be equal to, if you make it as a subject, we're going to have the u over what? Over 12x. So that's what we have now. Then we can go back to the question and begin to change the variable. So that will be equal to 4, 1, and then 24x. This is u. My ds is what? My ds is the u, 24x. And that's what we are looking for. We want this one to cancel so that we can have another variable. So x has cancelled now. So 24 over 2. So we can take 24 over 12, that's 2. We can take it outside, and then we have upper limit, that's 4, 1. Then we have 1 over u, du. So that's what we have now. And the integral of 1 over u is what? Is ln. So that will be equal to 2 ln u. Okay? Then we can return this function back to original function. Return the u back to original function. So anyway you see u, return this back, because this one, they are x is 4 at the upper boundary, x is 1 at the upper band, at the lower boundary, x is 1 at the lower boundary. So this will be equal to 2 ln 6x squared plus 1. Okay, then put your upper boundary for 1. So that's what we have now. So let's substitute and get the answer. For 4, that will be 2 can be outside, open your brackets, ln for the upper boundary, 4 square, that's 6 times 4 square, that's 6 times 16 plus 1, okay, that's the upper boundary, then minus ln for 1, substitute that also, that will be 1 square, 6 times 1 plus 1, that's ln 7, ln 7. So that's what we have now. So let's do this one. I think if we do this one, 6 times 16 times, so that will be equal to 2 into brackets ln 97, 6 times this plus 1, that's 97, and then minus what? Minus ln 7. Okay. So final conclusion, apply your law of logarithm. So that will be 97 over 7. So that's the answer. And if you want to go further, these two can come to the as the exponent here, as power here. And that will be ln 97 over 7 power 2. Okay. Another way you can also do this question, instead of substituting back the u here, we can change this value, this x equal to 1, x equal to 4 to u. We can do that. Okay, so that will be, we said let u be equal to what? 6x squared plus 1. Okay, so let's change the upper boundary and the lower boundary. So when x is 1, u is what? U is equal to 1 square times 6, that's 6 plus 1, that's 7. Okay, when x is 4, u will be equal to what? U will be equal to, that's 90, u will be equal to 97. That will be 6 times 16, 4 square is 16 plus 1, that's 97. Okay, so we've changed the upper boundary and the lower boundary to u, in the form of u. We've done that now. So the final conclusion, we just go back to where we have, this is our answer, 2 ln u. So that will be equal to 2 ln what? Ln u. Then the upper boundary is 97. And then what? And then 7. 2 ln 97 for the upper boundary minus ln 7. Okay? And the final conclusion, that will be 2 ln 97 over 7. If you use the logarithm rules. So when you subtract ln or logarithm, it will be division. Okay? So that's on that question.